What you see here is the fields program. At the beginning, it simply informs you what the screen dimensions are, just so you can be oriented. The screen dimensions move from -13 to 13 in the horizontal direction. That is, this side of the screen over here is at -13. This is +13. -10 here, +10 here. And it asks if we want a white or a black background, and I choose the black background for this purpose. Now, charge 1. What charge do we want to start with? I'm going to move in front of the screen here, so I think I might be able to set the keyboard up here. Okay, charge 1. Now let's just do a charge of 1 microcoulomb or 1 coulomb, whatever. Just 1 unit of charge. The computer doesn't really distinguish that much. And the coordinates of that charge, I'm going to put it at -4, 0. Charge 2, let's make charge 2 -1 at -4, 0. I think I did something really stupid there, but we'll get it back. Okay. Charge 1 at -4, 0. Charge -1 at 4, 0. I think I said -4, 0 last time. Okay. The program didn't do something it should have, but let's see what it did do. Okay, we plotted out equal potential surfaces and field lines around both of these charges. The field lines move out from the charges, okay, and they move out from this charge also. For some reason, they're not moving out from this charge, and I'll have to fix that. But let's see what we've got. Okay, field lines are like this, and the equal potentials are kind of like flattened circles, aren't they? Now, we're only showing the lower half of the distribution. The upper half is exactly the same as a reflection of the lower half. In other words, this distribution is completely symmetric about the axis because I put the two charges on the x-axis. Still a little mystified here, but let's go on. Okay, now, remember that this charge was +1, this charge was -1. That means we can see the electric field coming out of this charge and going into this charge. The field lines are the direction of the electric field. The charges are equal and opposite halfway between them. Well, what happens at this point? The charge here repels, the charge here attracts, you get a net charge to the right. Okay, a couple of other things. The field lines get further apart where the electric field gets weaker. Closer to the charges, the field lines are closer together. Further away, they're further apart. Less field out here than in here. The equal potential lines always run perpendicular to the electric field lines. Okay? Now let's look at the distribution that we have. The 5 microcoulomb charge 1 at a coordinate of, I'm going to put it at -4, 0. And I'm going to put my -2 at 4, 0. Again, my field lines don't plot over here. It might be because of a change I made in the program, so I'll have to look at that. Okay. In any case, we see a very similar distribution, but everything is shifted over this way. This is the greater charge, this is the lesser charge, and the greater charge has more influence. Its influence extends out further until the influence of this charge starts to overcome it. So the equal potential lines look like this. They bunch up here. The field lines look the way they do. And you're going to investigate this program for different charge distributions.